more of these where we're going to graph our data and look at our data points. Okay, so here it says, graph the data in the table. The nice thing is that graph's already set up for us. Decide whether the graph is linear or nonlinear, and then compare the two following objects. Which one has an increasing speed? So the first one, we have a falling parachute jumper. So at T on this is representing our time. I know I have that kind of cut off on the bottom, and I'm not sure if it tells you that in your book or not. It does. I accidentally cut off the very bottom of these graphs, but this T down here actually is representing time. Okay, so when our jumper jumps out at 0 seconds, their height is 300 feet above the ground. So over to 0 up to 300, we're going to go ahead and mark these off. It looks like every box is representing 30 on this parachute jumper. So this would be 270 here. So then 300 would be right here. Okay, our next one is over to 1 up to 285. So over to 1 up to 285. So this one's 240 right here. And then that would be 270. So 285 is going to fall kind of in the middle of that box. I know mine's slightly off. The next one is over to 2 up to 270. Okay, 270 is right on a line. Over to 3 up to 255. Over to 3 up to 255 is going to be in the middle of our next box above 240. And then over to 4 up to 240. Okay, so those are the only pieces of information that we have. Obviously, they haven't hit the ground yet, but it looks to me like we're going every time we go over a box, we go down half of a box. So this would be what you would call linear. I know my dots are slightly off, but it looks like a pretty straight line. Okay, so our falling bowling ball. So same concept, our graph is set up the same way. We have the time on the bottom once again. Okay, and every box that's going up for the height is worth 30. So like this would be our 270. Okay, this would be 210 here, and so forth. Okay, so we're gonna go ahead and at second 0, it's 300 feet above the ground. So they start off the same, at the same point. At 1 second out, it's at 284. So we're gonna have to kind of guesstimate. That's almost in the middle of the box, slightly less than half, but we're not really gonna see that when every box is worth 30, okay? So we're gonna go ahead and go over to 1 and about halfway up this last box. Not a whole lot of difference between second 1 here and second 1 on the bowling ball, okay? The height was 1 foot difference. Okay, so the next one we're gonna go at 2 seconds, it was at 236. So over to 2, up to 236, you can see that's gonna be just under our 240. Okay, at second 3, over to 3, it was at 156. So 150 is gonna be this line here. So 156 is a little above that. And then at second 4, over to 4, up to 44. So this is our 30 block, right? So 44 would kind of be in the middle of that block and the 60 block. So somewhere in here, whoops, my board's off on the bottom. Somewhere in there. Okay, but we can notice just from doing this, if I connect my dots, that it fell off dramatically as we graphed those. Okay, it's not a gradual fall, it's happening very fast. So this would be a nonlinear because it's not a perfectly straight line. Okay, and it also wanted us to compare the two following objects, which one has an increasing speed. So if we notice, our parachuter looks like they're going at the same speed. They're dropping about 15 feet every second. If we were to go through and kind of compare our height change to our second changes. Okay, in our next scenario with the bowling ball, well, it starts out 16 feet in the first second, but then it drops pretty dramatically, and by second 2, it had dropped from second 1 another 48 feet. So there was a change from 16 feet to now 48 feet to about 100, not 100 feet, but 80 feet drop. So this one is dropping much faster. So our bowling ball says which one has an increasing speed? That would be the bowling ball. Okay, so basically out of this activity, you were just working with understanding linear versus nonlinear. They gave a couple of real world scenarios so that you could understand the difference between these. They gave you the data that you needed, and then you were able to visually see the graph. So once again, a linear graph is going to show us a perfectly straight line, whereas nonlinear is no longer a perfectly straight line.